right, let's finish up 922 and complete this application problem. So if you haven't gotten a chance to read it, it looks like we're talking about in 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Do you know where these trees are today? Are they still alive? Comment if you know the answer. Similarly, the nation of Cameroon plans to give flowering SATA, SATA, I have no idea how to say that word, some flowering trees to other countries this year. When asked how to decide which trees make good gifts, Cameroon's arborist, I think that's a flower specialist, explained, we plant trees when they are 6 centimeters tall. 6 centimeters tall. So it looks like that's our tree's starting point, and they grow 9 centimeters every year. So if our trees are growing 9 centimeters constantly every year, hopefully you're thinking in your head, this sounds quite linear, where x, let's let x equal the number of years the tree's been growing, alive, however you want to phrase that, and y is the height in centimeters. Awesome. So that's kind of our let statements. And the trees only flower when they are taller than 150. All right, so we're starting the trees at 6 centimeters tall. So at year 0, they're 6 centimeters tall, and they grow 9 centimeters every year. We want to make sure that when we give these trees as gifts, they're taller than 150, because that's when they're mature enough to flower and be beautiful gifts. So let's see what this problem wants us to do. It is very important that the trees give flowers this year. It would be considered an insult to receive a tree that did not bloom. These countries sound a little greedy. Just be happy you got a tree. Anyway, luckily Cameroon has many groves of trees from which to select its gifts. So let's see, how old must the trees be so they will flower within the year? So I want to make sure the trees flower within the year that we give them as a gift. So A wants us to think, will this problem be solved using an inequality or an equation? So maybe we should go back to what the flower specialist was saying. The words that stand out to me is this phrase right here, are taller than. So it sounds like we have multiple answers for this problem. 151 centimeters would be taller than 150. 160 centimeters would be taller than 150. 200 centimeters would be taller than 150. So anytime there's a range of answers, the correct way to solve that problem is to be with an inequality. Part B wants us to write and solve a mathematical sentence to determine how old the trees can be so that they flower this year. So definitely we are thinking linear for this mathematical sentence. So you might want to go back here and determine which is the slope and which is the y-intercept. I always start with the slope because I think it's a little more obvious. Which one is the rate? Right here. I covered up the 9 a little bit there, but my slope is 9. 9 centimeters every year is our slope. That's our rate of change. And 6 centimeters tall, that's our starting point. That's our y-intercept. So it looks like my equation would be 9x plus 6. That is the expression that is for my tree. How fast is it growing? And that's going to tell me how tall my tree is at any given x, at any given year. and I want my trees to be taller than 150. It's not greater than or equal to, it specifically says taller. So that's greater than. So why don't we go over here and write down that mathematical sentence. 9x plus 6 is greater than 150. And now we can use the process we did in our first couple warm-up problems. We can solve for the boundary point. What is our boundary point? I get 16 years. That's a long time. Our next step is to throw that on an interval. So 16 would be over there, just about. And again, I like to test with the point 0 typically. Oops, I forgot to fill in or not fill in my 16. So let's do that quickly. Because this is a greater than and there's no or equal to, I can't accept the tree if it's equal to 150. That's just not going to work. It's too small. So at 16 years, I don't want that tree. It's not big enough. I want it to be greater than 150. There's no or equal to, so it's going to be an open point. Now we can plug in 0 to see if I shade to the left or to the right. I do want to pause and have us really think about this for a moment. Do you think we're going to shade to the left? Are we going to want the trees when they're little babies? I think we're probably going to want to shade to the right. We want the trees when they're a little bit older, more mature, and that's when they flower nicely, and that's the gifts we want. So let's see how it shakes out, but my intuition, and hopefully yours is too, telling you that we're probably going to shade to the right. And look at here, is 6 greater than 150? Absolutely not, that's not true. So we don't shade to the left, we shade to the right. We want the trees when they're a little bit older, so that makes sense. We want them when they're 16 years or older. Not 16 years. We want them when they're older than 16 years. 16 is not included. So our last step here is to write that as an interval. So it's going to be x is greater than, not equal to, 16. Not equal to. So the trees have to be older than 16, not equal to 16. Bigger than 16 years. Cool, we've got one more challenge for the day. Oops, I didn't copy it down in here. That's okay. It's in front of you. I'm talking about part C. I just didn't copy it into my smartboard, but you should have it in front of you. So later, and maybe you're almost thinking this in your brain, we do want them to be bigger than 16 years, but we know that eventually trees get really, really old, and they might start kind of falling apart and not producing flowers anymore. So that's what this is talking about. When the trees become very old, they stop flowering. Make sure you choose trees that are no more than 240 centimeters tall. So no more than. So can they equal 240? Yeah, as long as it's not more than that. So let's keep that in mind. So we're still going to use the same expression for the growth of our trees, but now we want to make sure that they are less than or equal to 240. And now we're going to follow the same process. Set it equal to solve for our boundary point. I believe that that is 26 years. All right, let's throw that on a number line. So 26, and is it going to be filled in or open? Because it is or equal to, it just says it can't be more than 240, but it's okay if it is 240. We're going to fill in this point. And now let's try to shade. So I always test with 0. So I'm going to plug in 0 over here so I get. And again, your mathematical intuition should be telling you it's probably going to be to the left, because now we're thinking about we don't want them to be any older than this. So it's probably going to be a less than situation, but let's see how it shakes out. So I get 6 is less than or equal to 240, which is true. So that means I do want to shade to the left. I want to shade with the 0 as part of the solution set. And so my inequality answer for this one would be x is less than or equal to 26. But wait, is anyone thinking, Shinners, you're not making any sense. First you told me x has to be bigger than 16. Now you're telling me x is having to be less than or equal to 26. You're right. We really have to put these two answers and really combine them together, because we first found out we need them to be bigger than 16, and then we found out that it has to be less than or equal to 26 years. So why don't we combine this as a final answer? This is our final answer to Cameroon. We need the trees. Trees should be older than 16 years, but younger or equal to 20, did we get 26? Yeah, 26 years. So we need the trees to be older than 16, so that's x is greater than 16, but younger or equal to 26. So that would be x is less than or equal to 26. And so the last thing I want us to think about today is how would I put these two things together on a number line? So let's draw one. Obviously 16 is the lower end, 26 is the upper end. 16 is an open point since I don't want it to be equal to 16. But 26 is a filled in dot because I said, hey, it's okay if they're 26 years old. And I would shade in between, right? I want them between 16 and 26. So that's kind of a fun interval. And now let's put these two into interval notation together. So we're going to have a sandwich situation. Here's our lower bound. Here's our upper bound. And x goes in the middle. So I want x to be bigger than 16, but less than or equal to 26. So that would be my final answer to Cameroon, so that they send beautiful trees to their country friends, and they are very happy to receive them. So I hope you enjoyed 922 lesson. Please, if you have extra time left in the class period, I would get started on the review and preview.